Hello everyone. Today we can discuss about how to implement the Boolean expression using a multiplexer in the subject digital principles and system design. So first we can see what are the steps. There are several steps for implementation of the merge using this function table. So first to write the function table, so you should list the input of the multi. What are the inputs? List under of them all the min terms in two rows. Like for example, if it is 16 bit information, 16 bits, 16 states are there means you are right as 8 and 8, first row 8, second row 8. The first half of the midterm is associated with A and the second half with A bar. So A dash A. So whatever terms you are going to give, you can take. The given function is implemented by circling the minterms of the function and applying the following rules to find the values for the inputs of the multiplexer. So if both the minterms in the column are not circled, then apply 0 in the corresponding input. And if both the minterms in the column are circled, then apply 1 to the corresponding input. If both the minterm is circled and the top is not circled, apply C to that is what is the corresponding that either A bar or A. And next to the is not circled, then apply C to the input. So one example we can see, implement the Boolean function using 8:1 as well as 4:1 marks. These is the minterms given. So how many inputs are here? 4. So n equal to 4. Because if it is n equal to 4, number of selection lines needed is n minus 1. So 3, S2, S1, S0. So we are going to use 1 to 8 as well as this much. 8:1 and as well as 4:1 much. So first we can go for 8:1 much for that design. The same thing I represented as 16 states, right? So 0 to 7 as 1, 8 to 15 as the second one. And as per the given question, 0, 1, 2, 4, 6. 0, 1, 0, 1, 2, 4, 6. Circle. Then 9, 12, 14. So 9, 12, 14 are circled. So this represents D bar D because the last input is D bar because as it is 4 bits. So D bar D. And in this particular, this is your input you are going to write. This represents the input. 0 is circle means D bar. Both are circle means 1. And the third column, D bar is circle. No, nothing is circle. And next, both are circled 1. So nothing is circled 0. Both are circled 1. Nothing is circled 0. Okay. So how to implement? So since it is an 8:1 merge, how many input lines are there? D0 to D7. So 8 input lines and 1 output line. 1 output line. Selection lines S2, S1, S0, 3. So these are the A, B, C. And we have taken D as the input, right? So D bar. So corresponding to this first D0, what is your input? D bar. And D1, 1. D2, again D bar. So based on this, you have to take. Then D3 is 0. So it corresponds to 0. Then D4 is 1. D4 corresponds to 1. D5 corresponds to 0. D6 corresponds to 1. D7. This is the way to implement your 8:1 match. So similarly, for implementing using 4:1 match, we have to divide this 8:1 match as two. One is 4:1 match, another one is 4:1 match. But you need to have only two selection lines. So we can take A and A bar as the two selection lines. C bar as an enabled line. So when C is 0, the first match is enabled, and when C is 1, the second match is enabled. So E represents the enable line. So the same concept, you are going to use D0 to D3, D4 to D7 in the bottom match, second match, and the D0 to D3 in the first match. So 4:1 match. Remaining conditions are, then you should add both, that is by using OR gate, you are going to add the output of all the four, that is the two match, and you will be obtaining as a single output since match needed only one output. Okay, so this is the way to implement the combinational logic circuit using multiplexer. Hope you have understand. Thank you.